addition, I start with electrophilic addition, right? Any doubts in that part?
No.
All right, perfect. Now let's just start. So basically, now we are going to do what? Okay. Now today we're going to extend that topic further, right? So in the electrophilic addition, right? In the electrophilic addition, what do you think we have? When we are dealing with the electrophilic addition, what does that mean? Just see. In the electrophilic addition, what do we have? See, so we have various reagents to be added up, right? And there are two different types of addition in the electrophilic addition. We know for the fact that this is a property of alkenes and
Yep.
alkynes, right?
Okay.
Now, how many different possible reactions we can see in this? So we can see the addition of HCl, we can see the addition of HBr, we can see the addition of HI, we can see the addition of water in the presence of H2SO4. We can also see the addition of water in the presence of borane, followed by H2O2 and a base. This is called as my hydroboration oxidation.
Okay.
Then we have this is acidic hydration. This is acidic hydration.
Mhm.
Okay. This is acidic hydration. Then we see the addition of bromine, chlorine, iodine. Primarily, iodine is not added, but chlorine and bromine. And we see the addition of hydrogen. So if you see the addition of hydrogen, you call it as hydrogenation.
Okay.
If you see the addition of chlorine, you call it as chlorination.
Mm-hmm.
And if you look at the addition of bromine, I hope you're writing down, that is called as bromination.
Yep.
So that's what we have, right? Also, we have the addition of water in the presence of mercuric acetate
Okay.
along with H2SO4. All right. That is another addition of, and this is basically called as oxymercuration, demercuration.
Okay.
Oxymercuration, demercuration. Okay. So this is one part. Now understand. So when we are dealing with the electrophilic addition reactions, these are various reagents we can add. One more reagent. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. And 10th that we have to do is NOCl addition. That is called as my Tilden's reagent. That is called as my Tilden's reagent.
TILDENS.
Yes.
Okay.
Right. So we have these reagents to be added up. Now, how do we work about them? Just see. Now, we have two types of electrophiles. We have two types of electrophiles. One is a classical carbocation, classical electrophile,
Okay.
and another one is a non-classical electrophile. One is a classical electrophile, another one is a non-classical electrophile. Now, when
Oh.
we deal with the non-classical electrophile, just understand what exactly is happening. See, in the electrophile part, when we are dealing with it, right? What do we see here? We see here that in the two types of electrophiles, classical electrophiles are those which carry a positive charge, but do not have lone pair,
Okay.
which carry a positive charge but do not have lone pairs,
Fine.
right? So in that category, only H plus lies. H plus is the only classical carbocation or electrophile we have. But let's say we are talking about Br plus. Br plus's name would be bromonium ion.
Okay.
Now understand a condition. Let's say there is a condition like BRF. Let's say this is some interhalogen compound I have. And
Mm-hmm.
let's say from here, bromine, this bond is supposed to break down under certain conditions. So you understand that fluorine is more electronegative than bromine. By being more electronegative means that fluorine has more power to pull the shared pair of electrons towards itself. So when
Right.
fluorine is going to pull the shared pair of electrons toward itself, it is actually going to break like this. That fluorine will take its own 7 electrons in the valence shell because fluorine's atomic number is 7. Fluorine's atomic number is 9. So configuration is 2 7. So fluorine has 7 electrons in its valence shell.
Hmm.
So thereby we'll have 1, 2, 3, 4, 5, 6, 7. And bromine also has what? Bromine's atomic number is 35. So this is also going to 1, 2, 3, 4, 5, 6, 7. But when this bond breaks, bromine acquires what kind of charge? Bromine acquires a +1 charge.
Okay.
So we had what? We had Br plus.
Hmm.
Are we understanding this part or not?
Yeah.
So Br plus is produced as a result of the heterolytic decomposition or heterolytic cleavage. You understand?
Hmm.
So if this electrophile is produced, I'm sure that bromine has lost only one of its electrons and still 7 electrons are left. So
Yeah.
when still 7 electrons are left, so we'll have what? We'll have bromonium ion.
Hmm.
Similarly, if let's suppose some bond like chlorine breaks, similarly instead of bromine, let's say if we have chlorine. So chlorine's atomic number is also 17. So its configuration is also 287. So it is also going to lose one electron.
Hmm.
And when it is also going to lose one electron, so chlorine also has 7 electrons in its valence shell. So we'll have 1, 2, 3, 4, 5, 6, 7. And
Right.
obviously in the sharing. So we have like this. So we'll have 1, 2, 3, 4, 5, 6, 7. So I hope you're understanding we're going to have Cl plus. That's nothing but what? Chloronium ion. Because one of its electron has been taken away by fluorine. So I hope you're understanding that we have what? We have 1, 2, 3, 4, 5, 6. So
Oh,
basically these are the electrophiles which have a positive charge on them, but also they carry a lone pair. So
okay.
they have this dual nature, right? They will also have a negative charge, like the lone pair, which is negatively charged, and they will also have a positive charge, right?
Hmm.
So, but because they're carrying a positive charge, you understand chlorine, bromine, these are non-metals. And non-metals, the basic definition of non-metals is what? That anything which can accept electrons. So
Right.
chlorine's regular nature is what? Atomic number is 17. So configuration is 287. So chlorine would want to gain one electron rather than losing. You understand?
Right.
So it would want to gain one electron and hence complete its octet. And the moment it wants to complete its octet, you see that Cl plus, it remains Cl plus, it remains Br plus. Are we
All right.
understanding my point or not?
Yeah. Now
So
I have
when
a
it
question.
tries to get, yes,
So chloronium ion, you said that's Cl and F. So isn't chlorine more electron, like the electron affinity of chlorine is greater than fluorine, right? So,
yes, definitely.
so shouldn't it be F plus and Cl minus?
No,
Because
we are not here talking about the electron affinity. We are here talking about the electronegativity. In the shared pair of electrons, electronegativity operates.
right, okay,
Electron affinity works in a very different way. I'll let you know that way. Right.
all right,
Now understand. So we have electro. So this is electro. These are electronegative elements, right? But
right.
what you are doing, you are kind of pulling one electrons from here.
Hmm.
So it becomes Cl plus.
Okay,
And the moment it becomes Cl plus, it is a more dangerous species. So moment it gets a negative charge, it attacks on that negative charge.
right,
Are we understanding?
yeah,
So that's the basic idea. So when we are dealing with Br plus, that's my bromonium ion and that's my chloronium ion. Similarly, if somehow O positive, just was the case we had O plus. So yesterday we saw that O donating one of its electrons to C plus.
yeah,
So then in that situation, O was acquiring a positive charge and it had a lone pair. So this is nothing but what? This is oxonium ion.
all right.
Are we understanding?
Hmm.
So the idea here is what? That when we are dealing with the two electrophiles, what does that mean? That we have a classical electrophile and we have non-classical electrophile. So generally, most of the electrophiles are non-classical, right?
Hmm.
Right? Because they will generally have a pair of electrons on them, and we will have a classical electrophile which is only H plus. Now, how does it work? Just see. So let us suppose we have. Let's talk about bromination. Now, if you realize that when we talk about any alkene, you know that alkenes are planar
Hmm.
and alkynes are linear.
Yeah.
Okay. So if I have to draw any alkene, they would all lie in this single plane. So they will have C, this is H, this is H. If I draw propene, so they will all lie in this plane. That means there is a top possibility. It's a planar thing, right? So there is nothing on the top and there is nothing at the bottom.
Hmm.
There is nothing at the top and there is nothing at the bottom. Are we understanding?
Yeah.
So what does that mean? So we will have the bromination part. So what do we say here? We say that we have alkene. They
Okay,
are
yeah.
planar and alkynes are thereby linear, right? So just understand that this is a planar species. Now,
Okay.
what happens is that we have, let's say, CH3, C, double bond C, H2, something like that.
Hmm.
And I have to keep this in my mind that it is going to be a planar structure. Understood my point?
Yeah.
Yes or no?
Yeah.
Got the point? Now understand. So now if I add bromine to this, and bromine you cannot add directly, you have to mix it in CCl4. So CCl4 here acts like a non-polar solvent,
Okay.
right? So you mix it in bromine you mix it in CCl4, and then you finally give me the answer. Now, how does it reaction proceed? Understand. So this is my reaction. I have to make the product. See, it is very evident from the fact that there are two bromine, one bromine will add up here, one bromine will add up here. That's what we know from our previous experience. But how
Right.
does it really work? Now understand. This time you have to understand that bromine and bromine. This is actually a non-polar molecule.
Yeah.
It's a non-polar molecule. Why? Because both sides we have bromine. So both of these electrons will rather stay exactly in the center. So if this bond breaks, highly likely this bond will not break to produce a bromide ion in a plus and minus form. If I talk
Hmm.
about HCl or if I talk about HBr, highly likely bromine will take one of its electrons of H. So then H will be produced as H plus and Br will be produced as Br negative.
Yeah.
But here what is happening? Here what is happening that we have Br2. So if this bond kind of breaks, so we get Br plus and Br negative. This is not happening normally.
Right.
But what is happening here? Just see. So we have propene, and propene's structure is something like that it has definitely a pi bond like this,
Hmm.
right? So they're overlapping at the top and bottom.
Yeah.
When they're overlapping at the top and bottom, so we have one electron coming from one carbon, from the red carbon, and one electron coming from the blue carbon.
Right.
So now this bond that is there, and obviously you understand that this bond is very unstable. Why? Because normally this bond would actually bend and then form. So
Hmm.
this bending is not stable. So this would open and close in order to gain stability from time to time.
Right.
So the moment this bond opens, now highly likely you understand we have this overlapping here. We have this overlapping here. There are two electrons in the center.
Yeah.
Now when CH3 hits, now there is a CH3 being placed here. What is this CH3 going to do? This CH3 is actually going to
Good.
donate one of its electrons.
Yeah.
So when this CH3 is actually going to donate its electrons, it is actually pushing the electrons to move into another orbital. So the moment this bond opens up, so the
Hmm.
moment this bond opens up, it opens up like this. Okay. So both the electrons, because of the push created by CH3, both the electrons shift into this carbon.
Okay.
And because both the electrons have been shifted to this carbon, so this carbon acquires a negative charge and this carbon acquires a positive charge.
Hmm.
Are we understanding?
Okay. Yeah.
So I hope you're understanding that we have Br and that's a non-polar molecule. Are we understanding my point or not? So
Yeah.
what do you think we'll have? So we'll have Br, and that is CCl4.
Hmm.
So now what is happening? So this CH2 negative, this is going to give electrons to bromine, because
Okay.
then, right? So this negative charge, when it approaches bromine, so there is a negative density, negative electrons density coming from this side. So when from this side it is negative is coming, these electrons they experience a repulsion, and then they basically start moving, shifting here temporarily. So that's a transient shift, right? The moment this negative charge, if it goes back, the electrons would again come back to the normal central position.
Okay.
So what exactly is happening here? So we'll have CH3, we'll have CH3, we'll have C. This is carrying a positive charge. This CH2 negative, because it approaches the bromine, the other bond. So this bromine bond starts to weaken up. And because it starts to weaken up, what does that mean? We'll have this.
Yeah.
and this
Okay.
bond kind of breaks. So
Got it.
you understand. So from here, what are we creating? We are actually creating Br negative, and this is nothing but what Br positive because its electron has been shifted towards another bromine. So bromine. So during the reaction, this bond basically is broken down in force to Br negative and Br positive. Are we understanding this pattern?
Yep.
Okay. So the idea here is what that we'll have CH3, we'll have C plus and CH2 negative, and we'll have Br, Br.
Hmm.
Understood? So
Yep.
now, so this is basically during the reaction, this bond breaks. Similarly for chlorine, similarly for hydrogen, similarly for all the non-polar reagents who produce the attacking species, they are not broken down on their own. They are being broken down by the alkene itself at the time when alkene's pi bond opens up. So,
Okay.
so we have this, and how is it shown in the books? It is shown like this: that this pi bond attacks here. Because pi bond is a movable bond, pi bond will open and close. The moment it opens, the negative intensity tries to attack on bromine, shifting the
Hmm.
electrons towards another bromine, and thereby this bond weakens up, and we will have CH3, CH, single bond CH2, and a new bond will be formed here. So this is going to be some transition state.
Okay.
Transition state is where new bonds are being formed, and old bonds are broken. Where old bonds break and new bonds are formed. Old bonds break and new bonds are formed.
Okay.
Got the point?
Yeah.
So we will have new bond Br being formed, and here the positive charge retains, and we have Br negative. Now understand, because Br is a non-classical electrophile. So how does it happen? It works like that, and also it is carrying a positive charge. So this might be carrying a delta positive and delta negative. So this is what is being formed. What is in formation? It is bromonium ion is in formation.
Okay.
Got it? Now you see, this is basically a structure where bromine is present. And we know for the fact that bromine, this was what? This is CH3,
Hmm.
right? Something like that. So it's a planar structure.
Yeah.
And bromine has connected itself, has been able to connect itself here. Got the point?
Yeah.
So we'll have 1, 2, and 3. And we have a positive charge here. Yes or no?
Yeah.
So once we have a positive charge here, what does that mean? Just tell me that we have this lone pair.
Hmm.
And this
We.
lone pair will do what? This lone pair will basically get attracted on the bottom. It will get attracted towards this positive charge.
Yeah.
So it temporarily makes a bond here. Now, it temporarily makes a bond here. What? It donates one of its electrons to carbon,
Hmm.
and obviously carbon becomes neutral,
Okay.
right? And bromine acquires a positive charge, and they both make a bond. So that bromine doesn't end up losing its electron. So bromine acquires a positive charge in that process. So this process looks something like this: that CH3, C, C, H and H, and at the bottom bromine is kept, and that is making a bond with both the carbons, acquiring a positive charge.
Okay.
So this three-membered ring that is being formed is highly, highly unstable. Three-membered ring
Right.
is highly unstable. And because it is highly unstable, you realize the fact that this bond, this ring is being formed again for a transient amount of time. But the moment it gets a chance, and to make this ring unstable, there are two reasons. Bromine carrying a positive charge is not a stable thing. Why? Because bromine is again a non-metal.
Right.
Any non-metal cannot carry a positive charge. Oxygen cannot carry a positive charge. Chlorine cannot carry a positive charge. So by
Hmm.
any sense, so basically now two things are happening. Bromine can't carry positive charge. So
Right.
to compensate for this positive charge, and how is that it has been able to acquire that positive charge? It has been able to donate its electron to carbon, make a coordinate bond. But in that coordinate bond, bromine has acquired a positive charge. So you realize that we'll have CH3, CH, C, HNH, and bromine. Understood my point or not?
Hmm.
And thereby, what is happening? Thereby, what is happening? The bottom area, the bottom of the plane, or the area under the plane is locked, is acquired, is actually occupied. So area under the plane gets occupied. So there is nothing that can attack from the bottom area, from the lower area. Why? There is nothing that can attack from the lower area. Why?
Because there's a bromine there. Bromine
Yes.
plus.
So now we have this bromide attacking. Now, obviously, what is happening? This bromonium is not very happy donating its electron, but because there was this lone pair of electron, it got attracted. You understand? So it's like that. So now what is going to happen? Bromonium is going to, ask for its electron. And
Hmm.
when it is going to ask for its electron, it is actually going to break the bond. And again, this bond will have a tendency to go back to bromonium. So in that
Right.
process, now bromide will attack C plus, and thereby this C will have a partial positive charge. So bromide will attack on the second carbon here from the top.
Okay.
All right. Why it cannot attack from the bottom? Because that space is already occupied, and there is no space to attack from other side, from the
Okay.
bottom side. So thereby, how what kind of attacks takes place? So if I show you it that way, so we will have this structure, and we will have CH3, we will have C, H, and H, and H, and one bromine attacking from the bottom, another bromine attacking from the top. So
I,
it is an anti addition. But anti addition happens only in case of non classical carbocation, non classical electrophile.
okay.
Any doubts on this?
No.
Got it. So this is one case. Now you understand that had it been the addition of HCl, so my product is what? So going forward, if I say that I'm going to have CH3, CH2, and I'm going to have a bromine, and in the presence of CCl4 as a solvent, and then I'm going to make CH3, C, CH2, and I can directly add the products like this. No issues. In writing, we do not. So, but this is a stereochemical aspect.
Okay.
This is a stereochemical aspect. Got my point?
Hmm.
So if I have CH3, CH double bond CH2 plus bromine, and we will have CCl4, so this is going to be the product. Now, how many products shall be formed? That is a different question. Now, that makes the question difficult. So,
Right.
multiple questions that can be framed on this part. That we have bromine, yes. Does bromine break down on its own? I'll say no. It
Hmm.
undergoes auto protolysis or auto breakdown. Why auto breakdown? Because during the reaction, the pi bond attacks forces bromine to break like that. Then
Okay.
we will
So,
have CCl for the solvent. One bromine attacks from bottom, one attacks from top. To be more precise, if you want, you can show it this way. To be more precise, if you want, you can show it this way. Understood my point?
yeah.
So you'll have CH3, C, Br, Br, and you have this part.
All right.
Got the point? So we'll have this part.
Yes.
Got it? Now, the amount of products that can be formed here, maybe two, maybe one, maybe four, it depends. Right?
On.
What possible questions they can ask you that do you see any chiral carbon here?
Yeah.
What is
Two.
a chiral carbon? A carbon which is connected to four different groups.
Yeah.
So if you look at this after the product is being formed, this carbon here is connected to one bromine, one H, one methyl, and one full of this group. So we'll have this as going to be my
Chiral
chiral
carbon.
carbon. So we will say that yes, we have one chiral carbon. And because we have one chiral carbon, there are possibility that one dextro part and one levo product is going to be formed. We'll discuss that later on in detail. But for now, sometimes they can ask you on the stereochemical aspects, right?
Okay.
So this is very important. Next we move on to the next part. Now, what is exactly happening? Similarly, if I have same CH3, C, CH2, and if I have the addition of HCl. So how does this proceed? Now tell me. Again we have what? Again we have the
Additional
plane,
in an H. Yeah.
right? Now we do not need anything else except this part. So what do you think we'll have? So we'll have this part.
Hmm. Because the H will add itself.
We'll have this part.
Yeah.
Got the point? So
Yes.
we'll have CH3, C double bond, C, H, H, like that. And HCl when it breaks down. And
Hmm.
HCl when it breaks down like H plus and Cl negative. Are we understanding?
Yeah.
So HCl, obviously, it breaks down. It's an acid, right? So it will break down into H plus and Cl negative. Perfect.
Hmm.
When it breaks down, so here it is producing an electrophile H plus. So again, now H plus is automatically positive. H plus will do what? H plus will attack it from any of the side. Let's say it attacks from the bottom.
Okay.
So how does it H plus attacks? H plus has nothing to do. H plus will simply go and sit at the bottom. And as
Hmm.
usual, the moment the pi bond opens up, the
Right. It's
moment the pi bond opens up, it will have one of its electrons here. And because of the push of CH3, this bond will go here. And yesterday we discussed that H plus kind of helps in the opening of the pi bond. So there are two factors which are actually making this pi bond open. One is the push coming from the CH3 electrons, and one is this H plus.
right.
So it makes the bond open in such a way that both the electrons they end up in one particular orbital. And
Okay.
hence, now H does not see what is the nature of H. H will have one proton and one electron.
Yeah.
So H is overall neutral, having one proton equals to one electron. That's H.
Hmm.
But you realize with the fact that once we have one proton and one electron when it is lost, so ideally H plus is nothing but what? One proton.
Yeah.
So that is why H plus is called as protium.
Hmm.
And every proton in chemistry, organic chemistry, shall be nothing but a proton. Simple. So you understand this H plus in order to complete its, the shell, it would first need its basic electron, H plus. So what is going to happen? This is going to donate one of its electrons to H.
Yeah.
So situation becomes what? If it is donating, so we'll have something like that. And one electron will be left with carbon and one electron will be left with hydrogen. And we will have a CH3 here and we'll have an H here.
Yeah.
So we'll have this bond here,
Hmm.
right? H gains one electron.
And isn't there a plus on the other carbon, the one that's connected to CH3?
That's there. Empty orbital is a positive charge. Empty p orbital is a
Polytron charge.
vacant p orbital. It's a vacant p orbital and that acquires a positive charge. That is as good as C plus.
Okay.
Okay. So that's what we have. Now we have a positive charge. Now understand when we have this part, you understand this H plus does not carry any lone pair.
Yeah.
H plus does not carry any lone pair. Because H plus does not carry any lone pair, what does that mean?
It won't block the other carbon. So
Right.
this.
So it has even if there is a positive charge here, it will not get attracted here towards C plus because there is no attraction between the neutral and positive.
Hmm.
Got the point?
Yeah.
And then what do you think is going to happen?
So the Cl minus can attack from any side, top or bottom.
Right. So Cl negative. So highly likely it will attack from the same side,
Okay.
right? It will attack from the same side. And when
Yeah.
it attacks from the same side, then what do you think? We will have. So there is a possibility. It can attack from both the sides, right? So we have a possibility that we will have CH and CH2. So this is going to be a syn attack. Here is H and there's going to be Cl. And obviously we also understand from the fact that there's a 2-degree carbocation being formed. And 2-degree carbocation is definitely more stable. So from here we have a Markovnikov's rule, which states that the negative part of the adding reagent, who is my adding reagent? HCl.
Huh.
And what is the negative part of the adding reagent? That is HCl, is H plus and Cl negative.
Yeah.
Are we understanding?
Hmm.
So the product so formed here will be what? CH3, C double bond CH2 plus HCl. And the negative part of the adding reagent goes to the carbon having more stable positive charge.
Okay.
That's the actual definition. I would call it as a modified Markovnikov's rule. That's a modified Markovnikov's rule. The main Markovnikov's rule definition states what? That the negative part of the adding region. The negative part of the adding reagent adds to the carbon having less number of hydrogens across the double bond.
Okay.
Understood my point?
Yeah.
So negative part of the adding reagent adds to the carbon having less number of hydrogens across the double bond.
Right. And how does it matter which side we attack from? Because like, don't single bonds constantly rotate? So if this is constantly going to rotate, then eventually they might come on the same side or come on a different side. So what's the point of a syn addition or a anti addition?
See, we will come to that. See, what you're actually asking to me is this. The final product will be something like that. Yes or no?
Yeah.
So even if it is in the syn or anti position, it does not really make a difference. I'll tell you why. Because final product will look something like this.
Okay.
So H and H will repel each other.
Hmm.
This H will repel this H, the blue ones.
Hmm.
And the red ones will be one behind the other.
Right.
So even if you're saying that this is going to be something anti, so you want to say that H will be here. We have here, right?
Hmm.
So we'll have a CH3 here. We'll have two H's here, right?
Yeah.
So this is my staggered orientation,
Yeah.
right? So after rotation, they might exist in any conformation. It does not make a difference. But while it is still in the planar form,
Hmm.
till that time, we have a plane to decide from top and bottom,
Okay.
right? H steric hindrance is almost zero.
Hmm.
H does not cause any steric hindrance ideally,
Right.
right? So that is why we consider that from the bottom, it is attacking,
Okay.
right? It might attack from the top also, it might attack from the bottom side also. The situation is 50-50%.
Hmm.
It hardly makes a difference. But since we have to define it into two categories of syn and anti addition, so what do we say? That when the bottom area is completely blocked, then we have absolutely no idea and no choice but to attack from the top and one from the bottom. But once we have a H plus attacking, right, then in that situation, the attack always takes place from the top. That's what we study in theory. It might attack from any of the sides.
All right.
We are doing it ideal concepts. It might attack from both the sides, and the product will definitely be the final one. This because that's where the repulsions are being the minimum,
Huh.
right? And final products needs to be stabilized.
Right. So in the second case, is there a
Hmm.
50-50% chance, or is it more probable that they'll attack from the same side as in CL?
Yes, yes, yes.
No, I'm not sure. So is it like 50% chance or like a 70-30 thing?
It's a 50% chance.
Okay.
Yeah. One second. Any doubts in this? Just let me. Okay.
Mm.
Now, so we have done addition of HCl. Similar goes with HBr also now. So you
Okay.
know that HBr will break down what? HBr will break down in the form of H plus
And Br minus.
and Br negative. So any alkene that comes across. So idea here was to tell you that when you are doing this, you understand.
You get Br either from top
So
or
you
bottom.
get CH2, the bond opens up. So how do you show it now with the arrow diagrams? You simply do not show the orbitals. Mechanism wise, how do you write this down? You'll say HBr will break down into H plus and Br negative. That's my step one. Then in
Hmm.
the second step, you will show the bond being opening up. NH plus attacking on this carbon like that. So
Okay.
you will have CH2 and H at the bottom, and write down that H is a classical electrophile here.
Hmm.
Got the point? And
Yeah.
then what do we have here? What do we have here? So this is H is a classical electrophile, and thereby Br also attacks on the bottom. So final product that we get is CH2, CH2H, and Br. Understood my point or not?
Yeah.
All
Got
right.
it. Yep.
Now, next, what do we have? Now we have the addition of. So HCl, HBr, you can handle by this. Again, we did addition of water. Hydration we considered, right?
Hmm.
We did acidic hydration in the previous class. Next, what do we have in here? We have the addition of Tilden's effect, Tilden's reagent. Tilden's reagent is nothing but NOCl. It is nothing but what? Nitrosyl chloride. Okay.
Okay.
So now the structure of nitrosyl chloride is something like this. All right. So nitrogen's atomic number is 7. Configuration is 2, 5. So we'll have N 1, 2, 3, 4, 5. Chlorine's atomic number is 17. So configuration is 2 at 7. So 1, 2, 3, 4, 5, 6, 7. And O is atomic number 8. So configuration is 2, 6. So we'll have 1, 2, 3, 4, 5, 6. So we will have this part
Yeah.
and we'll have this part. So I hope you're understanding that we're going to have N double bond O and Cl. That's the structure. And
Hmm.
the electronegativity order, the topmost electronegative elements:
Chlorine, oxygen, nitrogen, chlorine.
fluorine, oxygen, nitrogen. I remember it by the phone call order: fluorine, oxygen, nitrogen, and chlorine. These are the topmost 4 electronegative elements we have. That no matter what, fluorine is always going to pull electrons from oxygen and
Hmm.
nitrogen and chlorine.
Right.
All right. So
Hmm.
once we have this structure, now how does it work? Let's say I have an alkene. Okay. And I have NOCl attacking on this. Now, there are two ways of looking at it, right? Just see. So we'll have N double bond O and Cl, right?
Right.
So this bond opens up. Why this bond is being opening up? Because obviously CH3, CH plus and CH2. And this bond has to open up on this side, leading to the formation of a 2-degree carbocation.
Yeah.
And when we are dealing with a 2-degree carbocation, that is kinetically controlled process. Now, what do you mean by kinetically controlled process?
It's faster. Need to
It's
be more.
faster. Yeah. It's faster and formed in large quantities than the 1 degree.
Hmm.
All right. Now understand what exactly happens. So now obviously N double bond O out of phone call order, who is stronger?
Uh,
Oxygen is more stronger than nitrogen.
yep.
So this pi bond is a weaker bond. Obviously pi bond opens up and NOCl, if it is opening up like that, obviously O is going to pull the electrons because the pi bond is something like this.
Yep.
And when the pi bond is something like that, so it's going to be Cl, N, O, and both the electrons will be opened up towards O.
Hmm.
So when both the electrons will be opened up towards O, what does that mean? So it is going to be here.
Yeah.
So when this bond opens up, highly likely it is going to be opening up in the side of O. So we're going to have Cl, N, O negative, and N is going to be positive.
Yeah.
Okay. Now, so that's what it is. So basically, some books tell you that it is broken down like NO plus and Cl negative, but it does not actually break on its own, right?
Hmm.
The pi bond breaks first. When the pi bond breaks first, then what happens? We'll have N, O negative, and we'll have Cl. And this N acquires a positive charge because pi bond opens up. Because
Right.
of N carrying a positive charge, this attracts here.
Hmm.
and this attack takes place. So we'll have CH3, CH positive, CH2 attacking on NO negative and Cl. Now, nitrogen maximum has to make how many bonds? You tell me. Nitrogen's atomic number is 7.
Right.
So
So,
configuration is 2, 5. The quantum configuration is 1s2, 2s2, 2p3.
so to make
That
3 bonds.
means it needs to take 3 more electrons. And in the second subshell, in the second principal shell, you will have 2s being existing and
Hmm.
2p as the existing orbitals or subshells.
Right.
So once it gains these 3 electrons, I hope you're understanding what.
Then they'll go into P.
Yeah. So it cannot expand its octet,
No.
right? It cannot expand its octet.
Right.
So you will have this as 2s and 2p, right? So maximum it can do is it can form 3 bonds.
Hmm.
So when it can form only 3 bonds, what does that mean? That means it is going to attack here and we will have a O negative, right? But
Yeah.
NO bond, and see, understand, NO bond is a very strong double bond. P double bond O is a very strong double bond. C double
Hmm.
bond O bond is a very strong double bond. These double bonds are very difficult to break. So this O negative bond, which is obviously in the orbital, it tries to come back to its place, and hence, and then thereby Cl negative is lost.
Okay.
So NO thereby comes as NO plus. It comes across as NO plus. So if you see it, that because NO Cl negative is coming out of it, so people
Hmm.
say that it breaks down like this. But then the actual reason they are not able to justify, because obviously the electronegativity of nitrogen is more than that of chlorine.
Right.
So ideally it should have broken down like this, Cl plus and NO negative, but that's not happening.
Hmm.
So how do I put it into right place? I'm going to say CH3, C double bond CH2. We have NOCl. The bond opens here. We get negative here, positive here. The bond opens here. So in the next step, what is happening? CH3, CH, a CH2 negative and a positive here, and NO negative and a Cl here, positive here. This attacks here. This comes back. This released.
Okay.
So NO comes here,
Hmm.
and N obviously has a lone pair. So it's a non-classical carbocation, electrophile.
Right.
So next Cl negative will thereby attack from which side? CH3,
So,
CH, CH2, NO, and Cl negative will attack from the top side. So you will have CH3, CH, and CH2, and N double bond O.
got it.
Got the point.
Yeah.
So this is how Tilden's reagent basically adds up. So this is one part of it. Okay. So
Hmm.
NO plus that is being formed here, that is going to be my nitrosonium electrophile. You have to remember the name of NO plus. That is nothing but what? A nitrosonium electrophile.
Okay.
Understood my point or not?
Yep.
Got it?
Yes.
So that's the basic idea we have.
Okay. Now,
Got it?
yeah, what kind of questions do you get from this?
I'll come to that. अभी
Or
तो ये procedure पढ़ो आप अच्छे से है ना? So this is
ठीक है.
one.
Hmm.
Next, what do we have in here? So we have done addition of HCl, bromine, chlorine, iodine, all of it.
Yeah.
Now, तो sin anti addition समझ में आया?
Hmm.
ठीक है. ओके. तो ये हमने एडिशन कर लिया, है ना? अब इसमें एक टाइप देखते हैं. अब इसमें टाइप किया देख. CH3. Now, next topic that you are supposed to do here is migratory aptitude.
Okay.
What is migratory aptitude? Migratory aptitude basically means, see, there are general rules for the migratory aptitude, but also at the same time there are reactions for which the migratory aptitude is little bit different, right? But
Okay.
we generally study what migratory aptitude is. See, understand. You must have seen in the park the monkey bars,
Hmm.
right? अभी
Yeah.
उस monkey bar पे, if I ask a very light person to really cross the monkey bar from one bar to the other bar, to the end of
Hmm.
the bar. So a lighter person might still be lighter person with strong muscles would might be able to cross the entire monkey bar easily.
Yeah.
But you tell me a person who is little healthy and somebody who's little fat. And
All
if I
right.
ask that person to cross the monkey bar, will that be an easier task for that person? No.
No.
Right. So that person generally what happens is कि पार्क में मम्मी पापा जाते हैं तो वो बच्चे को नीचे से होल्ड कर लेते हैं उसकी लेग्स होल्ड कर लेते हैं
Huh.
and then what they do कि चल ठीक है you cross the monkey bar we are holding you will not fall down so it's a kind of support
Right.
you understand and then in that situation what happens the child might be quickly able to cross the monkey bar because there is no fear of falling down.
Right.
So understand one thing. So there are two aspects to migratory aptitude. Migratory means to migrate from one position to another. And why
Hmm.
do we migrate? Because see, we migrate from rural areas to urban areas because we have more stability there, we have more job opportunities. So
Right.
migration we do to get some stability. Now let's take an example. So let's say I have this carbocation and I have this structure. This is at carbon 1, this is carbon 2. Okay. Now we know for the fact that carbon, the positive charge at carbon 1 here is basically 1 degree because it is connected to only one carbon here.
Okay.
And because it is connected to only one carbon here, so we will have 1 degree carbocation. But we know for the fact that 2 degree, 3 degree carbocation is more stable than 2 degree,
Hmm.
than 1 degree.
Yeah.
So what exactly do you think is going to happen? That we are going to have CH3, CH3, CH2 plus. So then, so this carbocation has a urge to become more stable. It is already 1 degree. And it thinks
Hmm.
that if in the same molecule, if at all, I can be at this carbon.
Right.
So then I might be able to shift. But
Hmm.
shifting should give me more stability. Otherwise, I am happy where I am. So what happens
Right.
is that we have these two electrons being placed here and one here.
Hmm.
So when we have these electrons, what does that mean? That we have a positive charge here.
Right.
And because we have a positive charge here, so these two electrons, obviously this positive charge will attract the electrons.
Huh.
And because it is going to attract the electrons toward itself, what does that mean?
There's going to be a bond there.
So it's going to be CH3, CH3, this is CH2. And why is there an attraction? See, understand, every charge has a field.
Hmm.
Let's say I place a positive charge, let's say that's a 100 coulomb positive charge here. So it is going to create its field that, I am going to exert my influence in this area.
Hmm.
Any negative charge which enters this area will be pulled towards me.
Right.
So if it has this much field, any negative particle here will have actually no impact on this part,
Hmm.
will not be pulled towards this positive charge. But you understand the part. But if any negative particle is here in the field, it might get attracted.
Okay.
So this positive charge on this carbon, take it as a test charge, take it as a source charge.
Hmm.
What is a source charge? Which is a complete full positive charge, and then it is creating its entire field. And this field might reach. Now, if I elaborate this, you understand this CH3 might look something like that.
Yeah.
This CH3 might look somewhere like this.
Hmm.
This CH3, this is going to be H.
Yeah.
So this positive charge will be attracted here, will be attracted, might be attracting this. But which is the closest? This H.
Yeah.
So the closest particle experiences maximum force of attraction.
Hmm.
So that is why this H is experiencing some more force of attraction. So we don't show it that way. So we'll have what? We'll have a CH3.
Okay.
Are we understanding?
Yeah.
So when this gets attracted here, it would mean what? This is going to be an H here, and we're going to have a positive charge here.
Hmm.
Got the point?
Yeah.
Got it? So what do you think we're going to have here? So we're going to have CH3, we're going to have a C, we're going to have a CH3, and a CH3 here, and here the positive charge shifts. So here both the electrons, one belonging to carbon, one belonging to H, both makes a bond here, and this carbon 2 becomes devoid of the electron,
Hmm.
thereby generating a carbocation.
Fine.
So I hope you're understanding that we have now, and obviously, what is the reason of shifting? That it is converted from 1 degree to 3 degree, which is a sufficient amount of stability we have. So when we are dealing with this migratory aptitude, I hope you're understanding that we have this carbocation being what?
More stable.
More stable.
Hmm.
Got the point? So if given a chance, now understand. So here we have this bond, we have this bond, and we have this bond.
Hmm.
And these three bonds were equally spaced from this carbocation.
Right.
So when they were equally spaced on this carbocation, what does that mean? Just tell me that these electrons equally they were being pulled.
Yes.
But why only H shifted? Because H is the lightest of all. So the migratory aptitude of hydrogen is the maximum. No matter what group is connected, write down the migratory aptitude of hydrogen is maximum.
Okay.
Hydrogen is maximum.
Hmm.
Got the point. And because the migratory aptitude of H is maximum, so if we have a choice to shift methyl from here to here, and if
Right.
we have a choice to shift H from here to here, obviously H will shift than CH3.
Hmm.
Okay? Because H is lighter than CH3. Is that clear?
Yes.
Right. Now, similarly, so there could be multiple shifts. So this is called as hydride shift. Now, why it is called hydride shift?
Because the hydrogen shifted.
Right. Because H has shifted with its own electron and extra electron.
Hmm.
So ideally it is H negative getting shifted. Hence it is a hydride shift. But there
Um,
can be multiple shifts. There can be methyl shift. There can
okay.
be ethyl shift. There can
Hmm.
be phenyl shift. That means anything can shift. Now let's take an example. Some HCl molecule we have. Now HCl molecule breaks down to form H plus and Cl negative. So when this HCl molecule breaks down to form H plus and Cl negative, obviously you know H plus will attack. The bond will open. Once
Hmm.
the bond opens up, so we have CH3, C, CH2, CH3, and CH3, and CH2, and an H connects here, and
Yeah.
we acquire a positive charge.
Hmm.
So once we acquire a positive charge, what would that mean now? Again, this is 2 degree carbocation here, but it knows its potential that in this molecule, if I reach this carbon,
Hmm.
I will become 3 degree. Because if I break this bond, one of the bonds, if I break, and I become a positive charge, so one, two, and three. Three carbons would be connected to me, and then my stability would be even more.
Yep.
So I'll have 2 degree like that.
Hmm.
Got the point?
Yeah. So this would be a methyl shift, you're saying.
Right. Now here methyl shift will not take place. Understand? Here, what is going to happen in this structure? See, any shift can take place, right?
Hmm.
Now, see. Now let's come to this point. So let's suppose I have the structure C, CH3, C2H I'm breaking down as CH2, CH3. We'll have a CH positive charge, and we'll have CH3.
Hmm.
And obviously, there is shift has to be taken down. And we are going to mark the carbon having a positive charge as 1. And this is going to be a 2.
Right.
So now understand what is happening. So we'll have a CH2, CH3.
Hmm.
Got it? Now, this one might attract these two electrons. So when these two electrons basically move, you understand this carbon basically, see, once you move from one bar to another in the monkey bar, you lose one hand, you remove
Hmm.
one hand from the bar,
Yeah.
and you are trying to connect to the next consecutive bar.
Hmm.
So do you realize that your grip little bit loosens up on on the original bar.
Yes.
You feel like that you're going to fall down. And then
Yes.
how do you make your grip stronger? By connecting
To the next bar.
next bar. And then when you're moving the second hand back to the next bar, again you feel that thing.
Yeah.
But if somebody supports you from the bottom, you don't feel that fear.
Yes.
So what exactly is happening here? We have this one carbon, right? Once we have this one carbon, what does that mean? So we have this. Now this is shifting. So it is donating. So these electrons are getting shifted here. So this bond is actually breaking. When this bond is breaking and these electrons are shifting here, this carbon acquires a positive charge.
Right.
Same goes with this also. But you understand, but when these two electrons are shifting, electrons, this carbon acquires a positive charge. This positive charge will have a strong urge to pull back these electrons. Are we understanding?
Hmm.
So these electrons are shifting. They are on their way towards carbon plus. In that process, this carbon acquires a positive charge and it pulls back these electrons.
Right.
So shifting becomes difficult. But the same is happening with the C also. This is also happening with the C also.
Hmm.
But the moment they are shifting, it acquiring a positive charge, this CH3 donates its electrons or shifts its electrons to this C plus.
Okay.
So this C plus becomes less positive.
Hmm.
When it becomes less positive, these electrons, when they're on their path, this less positive charge will not be able to pull them back.
Yes.
And hence this shifting will take place easily and faster.
Hmm.
So thereby, out of methyl and ethyl, because we have a positive charge here and a positive charge here, this positive charge is being, I would say stabilized is the correct word as per chemistry, but this positive charge is being neutralized by the methyl group.
Hmm.
It's supported by the methyl group.
Okay.
And because it is supported by the methyl group, what does that mean? Because it is supported by the methyl group, what does that mean? That methyl group donates its electrons to CH2
Yeah.
and thereby the positive charge of CH2 plus decreases and it does not pull back. It does not pull back the electrons in transition.
Hmm.
And when it does not pulls back the electrons in transition, obviously this shifting of ethyl group becomes easier. So then, even though ethyl is a heavier group than methyl, it has a backing
Right.
and thereby it shifts faster.
Got it.
So if ethyl had to compete with H, then H would shift because H is lightest, it will shift in no time.
Hmm.
But if you have a comparison between two groups, one lighter, one heavier, look at the group which is heavier. Generally, what do we say? The heavier groups are electron rich groups because they have more carbons to donate their electrons. And the more electron rich they are able to sustain that positive charge that comes during the process of shifting.
Okay.
And hence that shifting becomes easier.
Hmm.
Got the point? So what do
Hmm.
you think we'll have? We'll have something like this. So we'll have CH3, C, CH3, one second. And we'll have a CH, and we'll have a CH3, and we'll have CH2, CH3 that's got shifted, and a positive charge comes here. And hence
Uh,
it becomes a 3-degree carbocation. And obviously that's the driving force.
hmm.
That's a 3-degree carbocation.
Okay.
Got it?
Yeah.
So if I talk about this migratory aptitude, so I hope you're understanding H has a faster migratory aptitude than
Hmm.
methyl, and then methyl se better is ethyl.